Alright, first rolling Tuesday, September 2nd. Welcome back from Labor Day weekend. So here's top mathematicians. This is if you did really awesome on that quiz back on Friday. There were some students absent, so if you're absent Friday in your class today, then we give you guys a makeup quiz. Yeah.
Can you read off all the names?
Oh well, you see them there, so here we go with that. Yeah. See your name then. Awesome, good job. Right. Yeah, make a quiz throughout. I do want to get everybody to take a quiz before I give them back. Right, so then you already did. All right, so we're doing module one. Well, this module is like a whole chapter. Right. Now, this module one, it's like chapter one, has 6 different lessons in it. So let's skim through those. What you big picture idea? You know what, too? Well, I've got this out. This is someone handed me one of these. The Powder Puff interest meeting is I think tomorrow in the media center.
This is the 26.
No, 26.
Wait, Abby,
Oh,
do you have to start practicing
This
now?
game day.
Yeah, show up to the media center tomorrow and they'll give you those details. I don't know anything more than on that paper. Anyway. All right, so we're in module one. Module one is it says down here in the try to get this on the screen. Right. In the bottom left corner says properties of functions. I guess on the even pages, properties of functions. And then on the odd pages, down here in the bottom right, it'll say what the lesson is. So lesson 1-1 is functions of continuity. Right. So guys, we're going to take all day today. Just look at 1-1. Here. You guys. Right. You got paper out? Paper out?
Yeah, there's just jargon on top map.
Okay. 1-2, we got linearity, intercepts, and symmetry. 1-3 is extreme and in behavior. 1-4 is sketchy graphs and comparing functions. 1-5, got piecewise, got absolute value functions. 1-6 is transformation of functions. Transformations is like how do you take a graph and like slide it to the right or to the left or up or down or maybe horizontal flip it or vertical flip it or stretch it. Now, I'm imagining that a lot of these topics might be like somewhat review. Maybe you've somewhat seen some of these things before. So like this whole chapter, this whole module, we might go a little faster on this one than some of the other ones. Like I know by the time we get to logarithms, you guys told me you haven't learned logarithms before, so I'll definitely take more time on that. Right, but all right, let's do this way. So I'm gonna solve some of these for you guys today. You guys write all these down. I'm kind of trying to figure out how I want to pace this out, and based on like how far I got in my earlier classes. So I think I might assign some of these to you guys tomorrow, but I didn't know how this going to pace out today. Right. So let's just slowly see how they today. Right. And what are the main concepts here? Now the main concepts are like domain and range. Right. So let's hit these first before we run into the questions. Right. Guys, what's meant by domain? What does domain mean? Yeah, possible x values. What are the possible values of x? Okay. And what does range mean?
Y.
Yeah, possible values of y. So if you have like an upside down parabola here, the possible values of x could go from what to what? Yeah, negative infinity to infinity. Right. So it could be also called all real numbers. Right? I mean, it's continuous, so it could be anything. Right. Right. But guess the y values only go up to what? Yeah, it looks like up to 0. So it looks like the y values can be negative. It could be 0 just at this one point, but it can't be anything positive. Right? So you have to somehow express that. Now, how do you express that? Your book gives you 2 different ways to do it. It's okay. Let's see. Well, I guess I'm getting ahead a little bit. So it's kind of going in order here. Okay. Yeah, let's just go in order just to stick to the book. So we'll round back around it. 2 ways to express things. Okay. All right. So guys, what makes something a function? Like there could be relations versus some relations are specifically called functions. After okay, so let's do this. Guys, what if you're tracking like the price of a stock as a function of time? The price of function of time. This looks like a y-axis. This looks like an x-axis. Could you maybe see something that goes like this? Maybe it goes up and it kind of comes down and goes back up and it's kind of maybe some kind of random walk like that, right? And that'd be realistic, right? Right. Would you ever see something like this? I say price as a function of time. It's like, okay, it's going up, it's coming down. Whoa, numbers backwards in time. Guys, is that ever going to happen? No, I've never seen anything look like that. Right? Is this even a function? No, right? No, so yeah, you'll never see price as a function of time, be something like that. Now, maybe something else. If I change this to a generic y and this to a generic x, I could call this some kind of relation, right? Some kind of relation, right? But you guys are saying this is not a function, not a functional relationship. I couldn't say y is a function of x, right? And one of the tests you can do, somebody called it, guys, what test am I doing now? This is called the what test. Yeah, vertical line test. Vertical line. You guys remember vertical line test? Okay. So if I sweep my roll like a vertical line through, well, if it is a function, like up here, this would be a function. So this relation is a function. But this would be a function, right? Where every, say, x value corresponds to one y value, right? Or t value corresponds to one price in this case, something like that. Right? So that works, right? But this one it would fail, right? So that wouldn't work down here, right? Now, what if something's 1-to-1? Well, what and that's here. That's what I'm trying to build up to, because that's this right here. Okay, if something is called 1-to-1, what does that mean?
Don't you think? Like,
Yeah. Not only is it a function, passes the vertical line test, every x value has one y value. Okay. But also, have you guys heard of a horizontal line test? Where maybe every y value corresponds to only one particular x value, right? Now, not all functions can do that. Like this clearly fails that horizontal line test. You say like, oh, what time was it equal to this price right here? It's like, well, there's actually three different times, right there, and right there. So I got three different answers, right? So this would not be what's called 1-to-1, right? But if you had a function where, okay, maybe something like that. Here, I'll change this back to x and y. Okay, so y versus x. Not only is there one y value per x value, but there's also only one x value per every one y value. That would be called a 1-to-1 function. Okay. Okay. So just kind of definitional stuff. Actually, a lot of this particular lesson is just laying the groundwork of how do you define things. What's this terminology mean? Blah, blah, blah. Okay. All right. So 1-to-1. So here, example 3. Guys, does this look like a 1-to-1 function right here?
Yeah.
Yeah. Right. Passes the vertical line test, so it is a function. Passes the horizontal line test. Yeah, so it's 1-to-1. Okay. How about this parabola? Is this 1-to-1?
No.
Right, it would not be. Yes, the answer would be no, because it fails the horizontal line test right there. Right. How about anything that's linear? Would that be 1-to-1? Yeah, anything linear. Okay. Eventually, I'll have you guys take inverses where we're gonna plot the x and the y axes. I think eventually that's going to show up, right? And when we start taking inverse functions, it has to be 1-to-1 to also create another function, right? Like this parabola, if you plot the x and the y, it would not look like a function anymore. Right? All right, what else we got here? I talk about continuous versus discrete functions. So something's continuous, it's just like you sweep some kind of curve through it or some line through it, right? Where say, well, what's the y value at x equals 3.1582, right? There's some y value there, right? Right. But okay, if it has a break, I guess, guys, if it has a hole in it like that break, would that be a discontinuity? Yeah, okay, so that would be not technically continuous because it's missing a point there. Right? And if you see something like this, where there's just looks like a scatter plot, you get individual points like this, that's called a discrete, right? So later on, you'll see stuff like that. Okay. Okay. Remember, I was saying there's two different ways to describe what's the domain and the range. Okay, so here we go. So there's a set builder and there's an interval notation. So if you see something that's like set builder, it always, well, okay, let's do this parabola down here because they start you out if you're following along with the book. They fill in part of this, but not the whole thing. Right, so I'll do this with you guys. Say some kind of parabola like that, right? Okay. So I might say domain, right? This would be set builder. Set builder, okay. Domain could go from, well, negative infinity to infinity, right? But there's a particular way you write it. So always start with a curly bracket like this. Then say x such that. So this vertical line means such that. So such that x. Okay, and then how you finish this off depends on what the domain is, right? But if you see something like this, okay, element of all real numbers is how I would read that. We're going to spell this out. Okay, so this funny looking character means element or element of, right, is an element of, right? And this looks like an R where I like double barred the R right there, right? And it calls all real numbers. Or I guess you could spell it out, but it's just easier to write the symbol. Okay. Okay. And there's other kinds of symbols too. Like there's one for like only the integers or only the whole numbers or something like that. But all real numbers is a common symbol. So see that. Okay. Uh, right. And then how about range? Okay. So range. Okay. Now range is the possible y values. So if I was looking at this parabola right here, oh, you guys see how it goes like from -6 to well infinity? Right. Right. Now they gave you the interval notation. See, it goes from -6 to infinity. Right. So let's talk about that. Right. Do you guys see how there's a bracket on the -6? That means you're allowed to include the -6, right? So -6 is included, right? And if there's a parenthesis, then it either means you are not allowed to include that specific value, or if you ever go to infinity, then as a rule, you always put the parenthesis on the infinity, right? But what about right? Okay, so that's the interval notation. But what about the set builder notation? So you get part of t. So we got y. So curly bracket y such that y, right? And then what? Right. Okay. Now here I can do looks like it can be greater than 6, but also equal to 6 or -6. So we can say greater than or equal to -6, and then close curly bracket. I'll do like that. Yeah. With that. Oh yeah. Right. Yeah. Right. So infinity in the x-axis is all the way to the right, and the y-axis is all the way up. Negative infinity would be usually all the way to the left or all the way down. Yeah. Yeah. So yeah, negative to the left or down, positive to the right or to the up. Yeah. Kind of practice. All right. So we got that. Okay. So that's set builder notation. Right. And then here I should actually draw out their graph to do the other one. Right. Because they're going to -6 here on the y-axis and then x-axis. Okay. They're doing something roughly like this, right? You got like a parabola, something like that. That's a terrible looking parabola. You guys get the idea. Okay. So let's do the other notation, which is interval notation. Right. Because we got set builder to look like this. Right. What's this interval? Right. So domain. Right. We're gonna go so spell it domain, or you could do capital D. That's fine. So for domain, right? Guys, kind of go all the way to the left and all the way to the right, like forever. Yeah, good. And how do you express that as a interval? Yeah, so negative infinity to infinity. There you go. Great. So the left value tells how far left you're allowed to go. The right tells how far to the right you're allowed to go. In this case, something like that. Right? And then put parentheses because we never go to infinity. Now the range. You're allowed to go as low as -6. Okay. What am I going to start this off with? A bracket. Yeah, a bracket. Okay, because you're allowed to also include the -6. So put -6. Okay. Now you can do anything above -6, right? Like you can do -3 or 0 or +5 or +5,000. So you go all the way to infinity like that. Okay. So that's interval notation. Okay. So these two, get rid of this. Okay. So I just showed you guys, this is two different ways to describe the domain and the range. Right? We've got this interval notation we just did, and this set builder notation we did a couple minutes ago. Okay, right, guys got those? Yeah. Okay. All right. What else is in this lesson? Boom. Okay. Yeah. If they break it apart like this, you can it skips some numbers in the middle. See how okay. If it skips them in the middle, so you have like these two different parts, you want to include those, you can include them with a union sign. You guys see that? It looks like a capital U right there, that union sign, right? At least in the interval notation, they do that way. And set builder, you just write the word or. Right. All right, so let's try some of these. Yeah, so I'll do some of these with you guys, and then Yeah, I'll look at these tonight. I might assign some of these to you tomorrow because there's funny questions here. So let's start real basic. How about number 2? This is lesson 1-1. Right. Guys, everybody follow along with me. Follow along with me. Okay, yeah, might eventually pick these up, I think, and give you guys credit for these. Or find some that are really similar to these. So number 2. Okay. What's the domain and the range for each function? Let's try it both ways. Let's do set builder notation, and then we'll do interval notation. Okay. So we need a domain and a range. Okay, a domain and a range. All right. Number 2, right here, this one. Okay. Okay. Guys, what would the domain be on number 2? Yeah, all real numbers. Okay. So using set builder notation, I'll go curly bracket. Let's see, there got actually, you know what? Yeah, you can write this, but x such that x is an element of all real numbers. Right? Now it's kind of fancy look notation. Looks like a lot. Or you could just write out all real numbers. That'd be okay too. So you could write in curly brackets all real numbers. That'd be right too. Okay. Right, and then for range. Now range, it only goes up to what? Yeah, 2. Right, so let's do curly bracket y. Here, how do you guys think you'd finish that off? Say, did you use such that y is less than or equal to 2? Like that?
Yep.
Okay. Like an inequality going on? Okay. Okay. Now, how could you communicate that with this other method, this interval notation? So domain, open parenthesis, and then write what right here? Yeah, negative infinity to infinity. Okay, because how far left can you go? Oh, all the way left. How far right can you go? All the way right. Okay. What about range? Yeah. Okay, there you go. So open parenthesis. Yeah, negative infinity. That's like all the way down. Right. So how far down can you go? Okay, well, as far as you want, all the way down to negative infinity. Okay, comma. Okay. Okay. And yeah, you can go as high as 2. Right, so 2. Right. Now, to finish this off, is how am I gonna close this off? With a what?
Close parentheses.
Close bracket. Aha. Yeah, you need that square looking bracket. Yeah, close bracket. Okay. Because if you had the parenthesis, you'd be saying that you're not allowed to include 2, but no, this crap goes all the way to 2. Yeah, y can be 2. So close bracket. There you go. Main range. All right, let's do number 4, sales. Sales. Got Pool Athletics introduced a new power sneaker in one of their stores. The table shows the sales for the first 6 weeks. Define the domain and range of the function and state whether it's 1-to-1. Ooh. So it's a little different here. So let's do domain. You can either spell it domain or just write D. Okay, and then range. Or just capital R's. Okay. Now, guys, this table of values, right? We have looks like whole value numbers of days or sorry weeks that have gone by, right? Like I don't see like 3.5 weeks. I don't think they're really considering that. It's just like either week 3, week 4. Like we're counting numbers, right? Okay. Do you think this would be continuous or discrete? Yeah. How do you guys think discrete? Discrete. Yeah. Guys, it's going to be a discrete function. All right. And for discrete functions, let's do this way. Always use a curly bracket. and just list the values. So the domain can be the weeks. So let's go 1, 2, 3. 4, 5, and 6. Okay. Right. And then for the range, here, let's see if we kind of put a story together. Looks like the first week there were 8 pairs sold. Is this pairs of shoes again? Yeah. And then, okay, it's going up a little bit, going up a little bit, going up a little bit. Ooh, and then week 5, it actually dropped in sales. And then week 6, it skyrocketed way up. Huh. Okay, that's interesting. Okay. Right. So what are all the numbers of sales? So, oh yeah, pairs sold. There it is. Okay, number of sales. Right. Well, I have an 8. I have a 10. There's a 15. There's a 22. Okay. There's a 15 again. So I don't have to double mention that because it's already counted for. I can say 44 sales. Right. And that would be the range right there. Okay. Now, the other question they ask is this 1-to-1? What do you guys think on that? Show of hands, do you think it is 1-to-1 or not 1-to-1? How many of you guys think that that would represent a 1-to-1 function? A 1-to-1. Who says that would not be a 1-to-1 function? Yeah, okay, I'm seeing a lot of you guys say that. Yeah, that's right. Not 1-to-1. How did you know it was not 1-to-1?
Because like it randomly
There's
dropped
two
down.
15.
Yeah, there's 2 15s. Yeah. Right. So if I ask the question, what week were 15 pairs sold? It's like, well, there's actually 2 answers to that question, right? Week 3 and week 5. So it's not that every y value corresponds to only one x value. Yeah. Okay, so do that. Okay. So definitely be a function, but in this case, not 1-to-1. Okay. All right. Just a couple other examples. All right, look, fairly similar. Right. Number 6, I just want to talk about real fast. I got so much class time, but let's talk about it. Right. It lists all these different planets. Their distances to the sun. Well, guys, look at those distances. They're listed in AU. Guys, what does AU stand for?
Gold.
Astronomical unit. Yeah. Oh yeah, true. In chemistry, it would be gold. Yeah. But in this context, it means astronomical unit. Okay. Guys, what is 1 astronomical unit? Yeah, you see it right here. It's given away. Yeah, the distance from the sun to the earth. Right. So everything's listed in sort of like Earth to sun distances. Okay. Okay. And you guys see the 4 inner planets, or like half an AU, 1.5 AU, and then there's a huge jump to Jupiter, and then all these gas giants. It jumps like way out there, out to like 30 AU. Okay. And then it's a corresponding orbital period in years. Right. Do you guys see like Earth is like 1 Earth year takes to go around. Right? Earth period. Right. You guys see the further away the planet is, the more time it takes to go around. Okay. That relationship is actually called Kepler's third law of planetary motion. A guy named Johannes Kepler figured this out hundreds of years ago. Now, the tie into here is they asked, is this considered to be discrete or continuous? What answer do you think they're looking for this particular example? Do you think they're looking for discrete or continuous? How many of you guys think they're looking for the word discrete? Who thinks discrete? Okay. And who thinks that would be considered to be continuous? Right. Right. So they're looking for a discrete. And I think the reason they're looking for a discrete is because they're just focused on these 8 planets here. Okay. Now, what if you had a question like, there's an asteroid between Mars and Jupiter, and it takes, okay, let's say we know it's like, I don't know, like 3 AU out, right? How much time does it take to go around? Do you think you could actually plot this in sort of like a continuous function and get a pretty accurate answer to that? Yeah, and that's actually what this is right here. This actually is the function right here. Right? Time is a function of distance. So this would actually be the continuous function. Right? I guess if you're just focused on a single or like a specific set of 8 planets, you could plot that, and they would just like individual points on a graph. All right, let's skip down here. Let's do number 8. Number 8. Actually, let's do 7, 8, and 9. Let's do all these. This will be fast. 7, 8, 9. Determine whether each function is 1-to-1. Now, first of all, are all 3 of these functions? Are they all functions?
Yeah.
Yeah, because they all pass the horizontal line test. You see that? All 3 of these are functions. They are functions. Okay. Sorry, they all pass the vertical line test. That's what I meant to say. They all pass the vertical line test. Okay. But what about the horizontal line test? Okay, let's go right to left. Okay, so start at number 9. Number 9. Is number 9 1-to-1?
Yeah.
Yes, it is. Yes, it is. Every single y value corresponds to exactly one x value. So yes, 1, 2, 1. All right, so number 9 is 1 to 1. Right. What about number 8? Is that 1 to 1?
No.
You're right, it is not. Not 1 to 1. Not 1 to 1. Right. It fails the horizontal line test. Ooh, like this, any of these y values have 2 corresponding x values, except for the vertex. Okay. Right. What about number 7? Would that be considered 1 to 1? What do you think? Here you guys say no? Right? Because yeah, if I say like, what's the x value where y is equal to 3? It's like, well, geez, x could really be anything. So yeah, it's definitely not a single value. Yes, that would be not 1 to 1. Fails the horizontal line test. Okay. So you guys got 7, 8, 9? All right, what else looks interesting? Example 4, he's right here. Let's do number 10. For 10. All right. Is this discrete, continuous, or neither? What do you guys think? Number 10.
Discrete.
Yeah, let's go discrete. Discrete. Okay. See how it's just like points plotted? Like back with the planets example, we could have plotted some distance and some corresponding period. It would just been 8 dots on a graph. That's all, just 8 dots. Or how about these shoe sales, right? There would have been just 6 points on a graph. Okay. Sort of like number 10, so except 3 dots. Okay. So discrete. Oh, that's okay. State the domain and the range. Okay. So let's do D for domain and R for range. Okay. Now, guys, since this is discrete, should I use parentheses or curly brackets? Yeah, curly brackets. Okay, so discrete, always do curly brackets, and then just list the values. So, ooh, what would you write to finish off domain right here? 2, followed by close curly. That's it. Just 2. Nothing else. Okay. Now, what's the range of this guy? Do I still need curly brackets? Yeah. And then, how do you finish this off? How about -3, -1, and 4? Is that what you guys just wrote on your paper?
Yeah.
Did you beat me to that? Because those are like the 3 y values. I got my own question here. Guys, would this be a function? Who says no, not a function, not a function? All right, there's my winners right there. All right, how'd you know this is not a function?
Goes
Fails the
vertical.
vertical line test. Yeah, I say what's the y value at x is 2. It's like, well, there's actually 3 different values. That doesn't work. Right? Notice in the setup, it doesn't even call it a function, which it shouldn't. Right? It says state the domain and the range of the relation. Ooh, right? Doesn't even call it a function. All right. Let's do 14, amusement park. Ooh, amusement park. So table shows the price of tickets based on the number of people in the group. So I think it's supposed to be like price per person, right? Price per person based on the number of people. Determine whether a function is discrete, continuous, or neither. State the domain and range of the function. Okay. So right here, I want to draw this out so this makes more sense. Okay. So we're going to put group size, and I'll put price per person on this axis. Okay. So if $26 is here, it's about $30. It's about $38. Sorry, it's kind of off a little bit. It's about start. Try it again. Okay. Price per person. I had this label too close. No, okay. Let's just scale this normal. Let's go 10, 20, 30, 40, 50. So 0, 10, 20, 30, 40, 50. Of course, the special prices are, looks like $26, which is right about here. Bing, 30, bing, 38, bing, and 45, bing. Right, those 4 values. Okay. And then here's group size on this axis. Okay. And what we got up to 15, so put 15 right here, up to 50, which is approximately here. and then 100, which is like over here. Right, so we've got these 4 groups. Okay. All right, good so far. Okay. So up to 15 people, you get $45 per person. Now I might think to make that a continuous line, like that. Okay. I don't think that's exactly what they're looking for though. Reason being, guys, can you have like 13 and a half people? Could that be a thing? Not really. Okay. So I think they want to make this more granular. So like if you had a bunch of points, I guess I would have what, like 15 points here, or 16 if I include 0. Right? So a 1, so if I had like 15 points, I don't think you quite fit that. I made this too short, but you guys get the idea. Could that be a bunch of discrete points? Right. And then what about 15 to 50? Well, not including 15. Right. So maybe the 16th person, they usually leave a little gap, and then the 16th person paid. Right. Now everybody in the group gets to pay $40. Yeah, 40. Did I write the number? No, sorry, it's 38. This is $38. This is 45. This is $38. Right. Right. And then I have a bunch of discrete points. Point, 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 point. I'm gonna skip a few just to get the idea. Okay. Now once you hit the 51st person, so if you have a group size of 50, everybody's paying $38. Once you hit the 51st person, the price for everybody comes down to just $30. So if the 51st person, it jumps down here, and then beep, 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 beep. Right. Imagine I have like, I guess like 50 dots going all the way up to 100. Right. Group size of 100, same price. But once you hit the 101st person, the price per person drops down again. Right. So then it goes something like this. And they got a bunch of dots. Right. Can you guys imagine that? Right. I think it's really what they're trying to get at. They're trying to get at. Right. All right. So with that in mind, right, now there's definitely some answers to these questions. Guys, would you call this discrete or continuous? Yeah, discrete. There you go. Yeah. So we're going to call this discrete. So domain. Here, let's just do this. Just write out this phrase. Write all whole numbers. Because like in principle, you could take this idea and like, okay, if there's 0 people paying, like 0 is a whole number, okay? And there's 1 person paying or two group. Okay? You have a group size of like 1 million, I guess, and that would technically be in this last category. Okay, so with that, okay. Now the range, this look more traditional, like what we've been doing. Okay, okay. Hey guys, how do you think I'm going to write the range? You curly bracket, and then what? It could really only be these 4 prices here, shouldn't it? Okay. So let's go 26, as in $26 per person. Okay, 30, 38, and 45. That's your only options for price values. So that's it. That's the range right there. Okay. Let's do let's do 15. Yeah, let's do 15. All right, 15. Groceries. A local grocery store sells grapes for $1.99 per pound. Ooh. Determine whether the function that models the cost of grapes is discrete, continuous, or neither, and then state the domain of the range. Right now, okay, I think you can kind of make a case for either. What do you guys think is probably what the book is looking for? Discrete or continuous? Continuous? How many guys like continuous? Continuous? Yeah, right. And I think the reason is you could buy any number of pounds of grapes, right? You could buy, I bought 3.1825 pounds of grapes. Yeah, okay, you could, right? Now, no, this really side thought. The answer is continuous. We're going for continuous. Right? But just as a side thought, right? I think you could say, well, technically, you can only pay in increments of pennies, right? So you could make a graph that looks like this, like pounds of grapes, and then like costs. Right? I think you could say, well, since you're only paying pound, you can buy any number of pounds of grapes. That could be sort of continuous, but number of pounds, right? I think you could make sort of a step function that looks something kind of like this. Right? But okay, that's really a technicality, so we're not going to worry about that. Yeah, we'll just call it continuous. In fact, if I make a graph out of this, I think it would just be a straight line, wouldn't it? And the slope of this would be price per pound. So this could be, what's it, $1.99 per pound would be the slope of that line, wouldn't it? Yeah. Okay, so we're going with that. We're going with that. We'll call it continuous. So continuous. Okay. Right. Domain range. Okay. And of course, we've got a couple of conventions for how to write these. Okay. Let's start with the set builder. So set builder notation. Right. So got curly bracket. Okay. See if you guys can write this out. What do you think it's gonna? So I started you out with the curly bracket. How's that finish off? Yeah, x. What's next? Such that at right. Now, can you buy a negative number of grapes? No. Okay. I could buy 0 grapes. That I think that would be okay. So can I say greater than or equal to 0? Right. That'll close that off. Okay. Or in interval notation. So that's set builder. This is set builder. Right. Let's do interval notation. Interval. So okay, the fact that you're allowed to buy 0 grapes, what should I start with? A parenthesis or a bracket? Bracket. Yeah, bracket. Okay. So let's go from 0 to okay. If I want to buy all the grapes in the world, well, mathematically, is that possible? I think so. Right. So I mean, you could take this $1.99 per pound just to however many grapes, right? So can I just like go like this? Is that all right? I have trouble fitting all those on Earth, but yeah, right. Okay. Actually, would the range basically look like the same idea? Right. So in set builder, you just change from X to Y, where Y now represents the price. I should say it, not the price, but the I guess the amount you spend on grapes. I guess the price would be the slope of the curve, wouldn't it? Okay. But the amount you spend on grapes. Okay. Or like this. There you go. And if you had like Bill Gates money and then spend all that on grapes for investment. There you go. All right. Let's do number 18. Okay, you guys ready for 18? 18. All right. Ooh. Now this is a funny looking one. That's why I picked it. Okay. They want you to use set builder and interval notation to describe the domain and the range. Okay. Guys, is number 18, is this a function? Yes or no? Yeah. You're right, it would not be a function. Yeah, it definitely fails the vertical line test, so it's not a function. They don't even call it a function though. They say, well, if they didn't call it anything, it would be a relation, I guess, right? Relation between X and Y. Anyway, we can still describe the domain and the range. So let's do set builder. All right, and then I'll go interval down here, domain, range, domain, range. You just do DNR, that's okay. What you're talking about. Okay, so let's start with set builder. What's the first thing you write for set builder? Yeah, curly bracket. There you go, curly bracket. Okay. And then since we're talking about domain, what letter goes here? X. Yeah, X. Right, such that yeah, guys, X can go from what to what? Positive. Right. Okay. So I'm gonna put this in like between inequalities. So maybe say -2 less than or equal to X less than or equal to 2. Because X is allowed to be equal to -2 or 2. That's why I also have to equal to. All right. There you go. That's what we're looking for set builder notation for number 18 right here. Guys, what about the range? Yeah, yes, yeah. So curly bracket y such that y is an element of all real numbers, or you could write out all real numbers. Okay. You guys saw that earlier today, right? Is an element of all real numbers.
It's a close one.
In your notes from earlier today. All right, so let's re-describe this as an interval notation. Is what's the interval for domain? Yeah, -2 to 2. Now, should I do parentheses or brackets? Bracket. Aha. Why brackets? Yeah, because you're allowed to also include these numbers. Right? You're allowed to include -2. You're allowed to include +2. Okay, so the domain does go that far. And then it's either like asymptotically never quite reached it. I'd have to close it with the parenthesis instead of a bracket. Okay. Okay. How about range from what to what? Yeah, open parenthesis. No, and then negative infinity to infinity and close parenthesis, just like that. A good case. Okay. All right, you guys good? All right. Ooh, this next few, it's a little funny. Okay. Okay. See if we can knock out one or two of these. So number 19, domain and range and set builder and interval notation for 19 right here. Okay. So set builder notation, and we'll do interval notation. Domain, range, domain, range. Okay. Now this one it skips some of the domains, so this one will be a little trickier. Okay, so let's do open curly bracket. Okay, x such that. What do you think that's going to look like?
Mine.
Okay, so x could be less than or equal to -1, and then write out the word or. X could be greater than or equal to +1. Okay. Because it splits, right? So if it jumps, right? Now you write the word or rather than and. If you wrote and, that also called intersection, it means that like, both things simultaneously have to be true, which can never be the case here. So that's why you do or. Like x be less than blah, 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 or could be more than blah, blah. Okay. Now the range I think is more straightforward. Guys, could y kind of be anything? Could y be anything? Yeah. And how do you indicate that? Y such that what? Y is in. How does this finish off? Element of
So right means
all real numbers. Right? That was a little easier, right?
You'll see like where it's.
Okay. Now the interval notation for this one. You guys ready for interval notation? Okay. It's gonna be something kind of new. Okay. Point this out real briefly when we were looking at the beginning of the section. Right. So let's go open parenthesis, negative infinity. Or so it's like all the way to the left, all the way up to -1. Now at -1, are you allowed to also include -1? Is that okay? Yeah, on the domain, yeah. Which means I'm going to close it with a what? A bracket, yeah, one of these little square brackets. Right. Right. Then, you guys remember how in the set builder notation I threw in the word or? You guys see or? Right. What's sort of the mathematical symbol? Because I only have half of the story here. I still need more. How do I write or in mathematics? It's this U right here. It's called union. Right. Here, I'll jot this down here. So this U means union. Or think of it like an or. Right. If you ever see the upside down version, that's called an intersection. Which you might see like on the Venn diagram, right? Like and that means and like both conditions have to be true for blah blah blah. Right. So in this case, we're going with or because you're either on the left side or you're on the right side. I'm going to open with a bracket and say 1 to infinity, and close parentheses. Range, guys. Could the range be anything?
Yeah.
So that be this open parentheses, negative infinity to infinity?
Yep.
Right. Last question. Guys, number 19. Is number 19 a one-to-one function? Yes or no?
No.
You say no? You say no? Right. How do you guys know that 19 is not a one-to-one function?
Why is
Just look at it.
Because it fails the
Vertical line test.
not the vertical line test, the horizontal line test. Right, it passes the vertical line test. Vertical line test is fine. Horizontal line test, specifically at y is equal to 0. You see at y equals 0, there's two different x values. Right. That's how you know that number 19 is not a one-to-one function. All right. So that is going to be our pause point today. You guys have a good day.